So yesterday we learned about multiplying a whole number by a fraction, and we used area models to help us do that. And today our lesson is about multiplying fractions. Okay, and our learning goal for today is we are going to learn how to multiply fractions using 3 different methods. Okay, so let's take a look at this problem. It says a class spent 3/4 of an hour practicing for a play. They spent 5/6 of that time singing. What fraction of an hour did they spend singing? What is that problem asking? Did they spend 5/6 of an hour singing? How much time did they spend singing? Aditya?
They spent 5/6 of 3/4 of an hour.
Good. So I want you guys to know when it's a fraction of a fraction, right? 5/6 of 3/4, the way you solve that is it's equal to multiplying the two fractions. So 5/6 of 3/4 of an hour is the same as 5/6 times 3/4. Okay, and do you see how this is multiplying fractions, right? We're going to multiply a fraction by another fraction. Please follow along in your math notebooks, okay? Okay, so here we have our equation, 5/6 of 3/4, which is the same as 5/6 times 3/4. And our first method is to use an area model, okay? So let's go ahead and first let's take care of the 5/6 part, okay? So how do I show 5/6 in this whole? What can I do? Riley?
So you split the model into
6 parts? Okay, so let's split it into 6 parts. Go ahead and follow along in your notebooks, please. Do I have 6 parts there? 1, 2, 3, 4, 5, 6. Okay, and what do I need to do, Riley?
shading 5 of them.
I'll shade it in 5 to represent 5, 6. So 1, 2, 3, 4, 5. Okay. How can I represent the 3/4 part then? That's my other fraction. Here's 3/4. Would you agree with me that this area model right now represents 5/6? Please follow along in your notebook. Yes, it represents 5/6, right? I divided it into 6, and then 5 of them are shaded. Now, how can I represent 3/4? Michaela?
So you draw a square.
I draw a square? What do you mean by draw a square? Okay. Well, but it's the same problem, so I want to draw it on the same one. So what if I divided it into horizontal sections for 6, right? Now what if I divide it into 4 vertical sections? 1, 2, 3. Now imagine those vertical lines, those are fourths now. Would you agree? So what if I colored in 3 of those? 1, 2, 3. So if you're looking at the red sections that go horizontally, that's 5/6. And if you're looking at the vertical ones that are blue, that's 3/4, yes?
Yeah.
So now if you're looking at, we multiplied 5/6 times 3/4. Now let's look at the sections that have both colors. 1, 2, 3. Does this one have both colors?
Yes.
The last one over here, does this one have both colors?
No.
No, right? So 1, 2, 3, 4, 5, 6. Does this one have both colors?
No.
Okay, 7, 8, 9, 10, 11, 12, 13, 14, 15. Does this one have both colors?
No.
Okay, so how many of those boxes had both colors? Hey, Mom?
15.
Okay, 15. Oops. So 15. And how big is each section? My whole is divided into how many sections now, Kevin?
The whole is divided into 15 fourths. Well, this is super confusing.
Mhm.
No.
So let's look. Look at the drawing. I divided it into 6 portions this way and 4 portions this way. So how many total boxes do I have when I divide it into 6 by 4? How many? 24. So 15 of my 24 sections were covered by both colors, yes? So this is my answer. Can I simplify this?
Yeah.
15 24ths. What can I simplify it to? 5/8. So that means 5/8 of an hour was spent practicing singing. So now please pay attention. Okay. Okay, method number 2 is to use multiplication and then to simplify. I think you'll find this one a little simpler, okay? So this is our same problem. We're still finding out what 5/6 of 3/4 of an hour is. So 5/6 of 3/4 is still 5/6 times 3/4. But what you can do now is you can multiply across the numerators and then multiply across the denominators.
That's what I was.
So what's 5 times 3, Jonathan? Okay. And what's 6 times 4, Sanjana?
24.
24. So do you see how I just put the multiplied across the numerators and then multiplied across the denominators? Can I simplify this fraction? Swati.
Five.
5/8 of an hour. Okay. So I want you to look back at method 1 and method 2. Compare method 1 and method 2. Did we get the same answer?
Yep.
Okay, so far so good. Then method 3 is to simplify using prime factorization first, then multiply. So what's the difference between method 2 and method 3? Archish?
So, the difference is we're using prime factorization in method 2, but, in method 3, but method
Sure.
2 is not.
Well, method 2, you first multiply, then simplify.
And you do the other way.
In method 3, it's switched around. You simplify, then multiply. So let's see what I mean by this, okay? 5/6 times 3/4, the same problem, right? Okay. Is 5 a prime number?
Yes.
Okay, so we can leave that up here. Is 3 a prime number? Okay, so we can leave that there. Our numerator is all primes, right? We only have prime numbers in our numerator? Very good. What about 6? Is 6 a prime number?
Nope.
So what would the prime factorization of 6 be? Ria? Good. So 2 times 3. So instead of 6 in the denominator, I'm going to write 2 times 3. Okay, what about 4? Can I just write times 4? Is 4 a prime number? What is the prime factorization of 4, Ruba?
2 times 2.
Good. So I can write 2 times 2. Okay. So do I have only prime numbers in the numerator? Do I have only prime numbers in the denominator?
Yes.
Good. Do you notice any common factors in the numerator and the denominator? Is there anything that's the same? Any same factors in the numerator and the denominator? Sonal?
They all are prime numbers.
They all have prime numbers, but do you notice any factors that are the same in the numerator and the denominator? Hemant.
There are 2 3s and
Ah,
3 2s.
So you notice that there's a 3 here in the numerator and a 3 in the denominator as well. So what's 3 over 3? What does that equal? 3 over 3 equals 1. So can we cancel these out because they're just 1?
Yeah.
When you multiply by 1, what happens to the answer? Does your answer change when you multiply by 1?
No.
Stays the same. So we can cancel it out. So here's our problem now. We've used prime factorization and we've simplified it. So what do we have in the numerator now? Dara? 5. And then in the denominator we have 2 times 2 times 2. What is that? Chris? What's 2 times 2 times 2? Chris, what's 2 times 2? Two times 2 is, don't think too hard, you can do it. 2 times 2, 4. And then what's 4 times 2? So then 2 times 2 times 2 is 8. Good, so 5/8 of an hour. Is this the same answer we got for methods 2 and 1? Very good.